Okay, hope you guys are doing well. We're going to start a new unit today, and this is Unit 6, which is all about probability. But today we're talking about what are called sets and the theory or the different, basically the vocabulary to go along with it and how to find different things as well. So this page is on the document if you want to print it out if you can, or you can just kind of follow along and write it on your notes, highlighting the big ideas, so that you have those as well. So there are 3 different things that we're going to talk about. But first, we just need to know what a set is. So a set is basically just a group. It can be of terms, items, elements. We call the items elements in the set. So like these are the elements of set A, 1, 2, and 3. Okay, universal set would be a set of all possible elements. And we'll get more into that later, but I just wanted to throw that out there to start with. Okay, so the 3 main things we're going to talk about are the relationships between sets. So the first one is called intersection, and the symbol that we use looks like almost like an upside down U here, so you'll see the difference between those. It kind of looks like an A if you were to draw a line right through the middle, but that is our word or symbol for intersection. So our definition, we want to think of intersection as what is in common, okay, between the different sets. So what elements do they have in common? That's the intersection. So if you think about where they cross, okay, that's going to be our intersection. So for example, if I have A is the set, that's what these little curly braces mean, of these elements, 1, 2, and 3. B is this set, 2, 4, and 6. Okay, it asks us to find A intersect B. So you need to be able to look at this symbol and recognize that that means intersect. Okay, otherwise you're going to say A, I don't know, B. So you need to be able to recognize that means A intersect B. Okay, so that means we need to find what elements or what numbers in this case do they have in common. So the only thing that's in A that is also in B is the number 2. Okay, A has a 1 and a 3, but those aren't in B. B has a 4 and a 6, but those aren't in A. So the only one they have in common is the 2. So A intersect B is 2. Okay, and that's a set on its own. You don't have to stress too much about the curly braces, but it's basically what do they have in common. So sometimes it's easier to visualize this. So you'll see a lot of sets written as Venn diagrams. And it's just like a normal Venn diagram you would see in English class where you're comparing and contrasting or what they have in common. So we'll draw 2 circles here because we have 2 sets. I'm going to label one of them A and one of them B. Okay, this middle part where they cross or where they intersect are the things that are in both set A as well as in set B. Okay, so if we look at set A, it's 1, 2, and 3, but the 2 is also in B. So we're going to put the 2 in the middle there, okay, and then A also has a 1 and a 3. So I'm going to put those in there. And then B has 2, 4, and 6. We've already put the 2 right there, okay, because it's in both sets. But then B also has a 4 and a 6, so we'll put that in that part of the circle by itself. Okay, so where they cross, now you can kind of see why we call it intersection, is the intersection or what's in common, what's in both sets. Okay, so that's intersection. So union is our next one. So union has a symbol that looks just like a U. So that one's a lot easier to remember because it's U, okay, for union. So I always think of union as like a marriage. You're going to a union, so you're bringing 2 people together or 2 families together. So that's exactly what union is with sets. It's think of union as putting 2 sets together. Okay, so you don't have to look at what's in common. You don't have to, eliminate. It's literally putting those 2 sets together. You could have elements that is, or it's going to be any element that is in at least one of the sets. The elements can be in both sets, and that's okay. You don't necessarily have to write it down twice because you've already written it one time, but it's allowed to be in both sets. Okay, so if I wanted to find A union B, all I'm doing is writing one set okay, by putting both of these together. So A has 2, 4, and 6, and I'm going to put that together with B, which has 1, 2, and 4. Well, we've already written the 2 and the 4, so we don't have to write it down again. Okay, so A union B are all of these numbers put together, which gives us 2, 4, 6, and 1. Okay, so in a Venn diagram, we're still gonna kind of create it the same way to start with. Hold on one second. Okay, the middle part is going to be what they have in common. So just kind of look and see. They both have a 2 and a 4, so that goes in the middle. Okay, A also has a 6, so that goes right there. And then B also has a 1, so that goes right there. Okay, so when I say A union B, it's going to be anything that's inside these circles. So 6, 2, 4, and 1. So it's going to be all of this. Okay, even though these are in both circles, it still counts as A union B. So it's just everything inside of the circles, including that intersection part. So intersect is where they cross. Union is just writing down all the numbers together. Okay, and then the last one is complement. And there's two different ways to write it. I'm going to use this little apostrophe a lot, but this means a complement, or you'll see a line over the top, which means the same thing. Okay, so we want to think of the complement as what is not in the set. Okay, so I kind of gave an example here in words. So if A is the set of even numbers on a dice, we're going to read this as what is not A. Okay, so if A is the set of even numbers on the dice, that would be 2, 4, and 6. Okay, so if we want to know what's not A, so we need to think about what else is on the dice that's not even. So that leaves us with 1, 3, and 5, my odd numbers. Okay, so it's going to be everything that's not in that set. And this is usually a little bit easier to calculate or see in a Venn diagram, so I went ahead and made one over here. Okay, so think of that symbol as not. So they give us this. L is this circle, okay, S is this circle, and we want to find what is not L. Okay, so this is L. That entire circle, which tricks people sometimes. What's not L is basically cover up L and everything else. So that leaves me Y and R. So not L would be Y and R. Okay, sometimes